Okay, this is assess page, what is it now, 129 to 131. I'll just do some selected questions here. I won't necessarily plot everything or do some lovely grids, but I'll still do the maths for it anyway. Question 4 says, copy this table of values for y equals, so it's an equation, y equals 3 plus half an x. If you don't like it that way around, just rewrite it. Y equals half an x plus 3. I much prefer it. And we're given these values, so I've got x going from -2, 0 and 4. That's what I've got, so that's what I'm going to work with, like that. And I'm going to work out my y values in a minute. So y equals 1/2 of an x plus 3. I'm going to try and make it fit in there if I can. Right, let's do their thing then. As I said, this is question 4. Y equals 3 plus half an x, or half an x plus 3 is fine. Here I go. I've got a half times -2, because that's what x is, plus 3. Half of -2, well, half times 2 is 1, so it's -1 plus 3. -1 plus 3 is 2. Therefore, I've created the point, wrong, I've created the point -2, 2, haven't I? Alright, so that's the actual coordinate that we can plot. Here, nothing times, sorry, that's not nothing, is it? It's a half times nothing. I'll get the same answer anyway. A half of nothing is still nothing, plus 3 would give me 3, so I've got the point 0, 3, and finally I've got a half times 4 plus 3, well, half of 4 is 2, plus 3 is 5. Look at the trend. I'll check that trend actually, it's not going up in the correct amount. Anyway, it's not the problem. The thing is, I've not gone from -2 to 4 in single steps. I've gone from -2 to 0 and 0 to 4. That's all required to do a straight line. So what we got here, half of 4 is 2, 2 plus 3 is 5. I've got the point 4, 5, and we'll plot that. We'll get a gradient of a half, and it will cut through the y-axis and form a y-intercept of 0, 3. That's what that says. That's all I want to do with that. Question 5. Which of these points lies on the line 4x minus 3y equals 4? I'm just going to pick a random one. I'm going to pick the point 7, 8. That is part E of question 5. So I'm testing out the point 7, 8. If that point lives on the line, then when I put the 7 in the x and the y with the 8 together, I should get an answer of 4. Let's test it. 4 lots of 7, not plus, it's minus 3 lots of 8. Let's have a look. 4 7s are 28. Take away 3 8s is 24. 28 take away 24 is 4. That's a score. That deserves, you know, a yellow sunbeam all around it. Lovely, lovely, lovely. So therefore 7 8 lies on the line 4x minus 3y equals 4. Is that alright? Lovely. Right, that'll do. I'll pick question 6 now because it asks me to work out the gradient of each of these lines. Let's pick this one here. Y equals 5x minus 1. There's the number in front of the x. The gradient is 5. End of story. How about this one? 3x plus y comes to 2. I want to get it in the form of y equals mx plus c. So y equals 2. You get lost next door, minus 3x. Straight away, standard yellow practice, the gradient is a minus 3. It's a negative gradient and it will pass through the point 0, 2, coincidentally, or incidentally rather. Now, how about this one? Y minus x equals 3. I don't want to minus x, take it over and plus it. So you get next door and you get added to your mate. So that's going to be 3 plus x. In other words, y equals x plus 3. And I've got a single x there. Therefore the gradient is 1, because I've got 1x only. Fair enough? Turn over. Now, not doing that. I rather like question 8. I'll sort of try and draw it for you. I've been given a grid like that, and like that. And I've been given a line that cuts across like that. And I have been told, that's the point A, just there. And that's the point C just there, and the point B is out here somewhere. Now it's been craftily done. I really don't like this, but anyway, I'm told the gradient is minus 2. So I'm going to point to that and say gradient is minus 2. and I'm told that B to C is 4 units. So from there to there, from B to C, 4. So the x width, the x horizontal length is 4, and therefore I've got to work out what the length AB is from there to there. Now, no worries, forget a negative gradient. I know that the y divided by the x is going to be a gradient of 2. It doesn't matter whether it's negative or positive, because we're trying to work out an actual length here. So if my x is 4, let's put put the y over 4. So as before, it's a standard equation. Y equals 2 times 4, so y equals 8. Okay, so there it is. The length of the line AB or BA is 8. Just playing around with the gradients of -2. Now what have we got here? Question 9. Just make it fit here. I've been given a little storyline like this. I've been given one of these. I'll draw it again here so it looks a bit like that. Not too flash, is it? And that passes right through there. I'm trying to be accurate as well. And we're told, Jackie says the equation of the graph is y equals 3x plus 4. Does read it's question 9. Explain how you can tell by looking at the graph that she is wrong. Alright, so here we go. Plus 4 means the graph has to pass through the point 0, 4. So using y equals 3x plus 4, the graph should pass through 0, 4. Okay, but it passes through the origin. And the origin, of course, is 0, 0. And there you go, it's a good enough answer, right? We're passing through. Why is that all squiggly diddly like that? Get rid of that. Should pass through the point 1, 4, but it passes through the origin 0, 0. So the equation can't be right. Now, question 10, I'll make it fit here because it's in a similar sort of vein. I've got this graph thing here. It looks a bit like that, and it looks just like question 8 on the previous page. But anyway, here it is, got a graph like that, and we've got two guys arguing. One says this is the equation, y equals x minus 5, and the other guy says no, this is the equation, y equals 5 minus x. And the question is, who's got it right? And explain how you decided. Okay, let's just test out the first one. Here we have y equals x minus 5. It has a positive gradient because it's 1x. But the line has a negative gradient. And what about this minus 5 then? The intercept must be 0, 5. Okay? But the equation shows that it is 0 minus 5. Again, because the minus 5 there. So is that alright? That's got a positive gradient and passes through 0, minus 5, whereas this has got a negative gradient and passes through 0, 5. Let's just test it here then. Do we have a negative gradient here? Yes, it has a negative gradient of minus 1, and it passes through the point of 0, 5. So that is definitely the point 0, 5. And it matches the 5 there. And here we have a negative gradient, hence the line going from left to right, going from higher to low. So that's that done, and that'll do with the assess, and that's the end of part 10 for everybody. Thank you.